going to start today talking about quantum physics and Schrödinger equations. Everybody's ready?
Okay.
Yeah? Now we're just going to give a few examples on AI. So I met Natalia last week. We ran into each other at a conference in Malaga where we both live. And I told her, I think we are together at a panel in Amsterdam next week. And that's how we started doing the panel. I'm going to show you a little bit of what UI is doing and what Sandbox AQ is doing. Both of our companies, even after we met, we have a partnership for a long time, for 2-3 years. But everything we're going to talk about is those are things that we're doing together. I think we're going to start with a video that I saw the other day that Natalia will show.
For possible futures for AI. There is no single path. Rather, there is a spectrum of possibilities. Constraint. AI's figures become public. Trust in AI erodes. Governments step in. Innovation stalls with increased regulation. Growth. AI accelerates rapidly. Capabilities evolve. Innovation explodes. Businesses become increasingly efficient, driving performance. Society thrives. Transform. A groundbreaking shift in AI. Single-employee AI-led startups. AI and humans collaboratively reimagine what's possible. Creativity flourishes. Limitless potential. Collapse. Concentrated power drives AI winners and losers. Tech monopolies grow, market value collapses. Jobs hang in the balance. You have the power to make decisions today that will shape your tomorrow. EY teams can help you prepare, no matter which future unfolds.
I promise this wasn't supposed to be advertising EY. But actually I wanted to show it to you, and I wish I had a way to poll you and see which future you think we're heading towards. But I think the point isn't to predict the future. The point is to actually prepare for that future. And that's what we're trying to do with some of these scenarios. We got together with clients, industry experts, strategists, futurologists, to really try to understand what could happen by 2030, and what could that mean for our businesses and organizations and our society. And I think it's really, really important that we start thinking about it today and now because of the speed of this technology. I know a lot of you will have seen our booth outside, and we do a lot of this exercise with clients to try to understand, how they should prepare. But Fernando, as you think about this emerging technology, this next frontier, and the scenarios that we've seen, how do large quantitative models change the game?
Yeah. How many here have heard of quantitative AI? Can you please raise your hand? Okay. How many engineers or physicists, scientists do we have in the room? Perfect. So I'm going to explain a little bit about what quantitative AI. It's an evolution of generative AI, what we're doing with biology, physics, chemistry. But Natalia told me she had a video, so I begged our marketing team to have a video as well. But I asked it to be less than 1 minute. So it's our mathematician Star, and she explains large quantitative models much better than I'm going to do.
You've probably heard of large language models, or LLMs, like ChatGPT, Gemini, or DeepSeek, which are amazing tools for solving language-based problems. But not every problem is a language problem. The physical world doesn't speak to us in words, it speaks to us in numbers. We learned long ago that words are not enough to describe, understand, and ultimately control nature. The right tools for the job are numbers and equations. That's why large quantitative models, or LQMs, are the next evolution of AI. At their core, LQMs are AI that's anchored on the fundamental equations of physics, chemistry, and biology, and trained on data that's generated directly from those first principles equations using proven mathematical methods. LLMs are still part of the story, but with LQMs, we're adding other kinds of tools to the toolbox.
So, many of you have played with LLMs, Gemini, GPT, your favorite, Anthropic, and we know it's based on words. It's trained with the internet data, and words, unfortunately, they don't manage or explain the world. Like the world that we live at today, it's made out of physics equations, chemistry equations, equations that have been there for 100 years and that have been proven. So when we think about LLMs, how we play with words, it makes us think that it's reasoning, that it's really thinking, because it's the way we use to communicate between humans. But they are not really thinking behind it. If you know about transformers, for example, that is the technique that it uses like large language models. Transformers is a statistical model that tell you what is the probability of the next word that is going to come after you write something like the capital of France is, and it's going to calculate what the next name of the city should be. But it's not really thinking, you add 2 plus 2, it's not really thinking 2 plus 2 equals 4. It's just certain the probability of 4 being the next best result. And you find that sometimes you find very easy questions that they give you the wrong answer. Like what is 2025 minus 15 years? I might tell you it's 2050, something like that. So we see LLMs have a huge impact on entertainment, customer support, marketing, because it's very easy to generate content. Words, images, videos, we see it. And software engineering. You see all the big tech companies right now have said, we are not hiring any more software engineers. Because now for coding, we're asking our software engineers to use AI and to code the same amount of productivity as 3, 4, 5 engineers than you used to be able to do before. So for those areas are very useful. But for the main principles of the economy, of the GDP of a country, like manufacturing, production lines, financial services, aerospace, that runs a country, it's not going to have a huge impact. That's when we enter the large quantitative models. When you design a car, when you design a new pharma, a new drug, you don't use words. You cannot ask a GPT, can you give me the cure of Alzheimer? It's not going to answer because it's not going to find the answer anywhere. You have to run chemistry equations, biology equations, physics and quantum physics equations with AI and run those ones. In fact, we have a very good example. We work with Nobel Prize Stanley Prisoner on Alzheimer. And he had a plan to go to lab in 6 years, in 2031, and say, can you simulate what I'm trying to do? I'm trying to blow up the protein, the prions that cause Alzheimer. We ran the large quantitative models and we were able to simulate in few months what he was planning to do in 6 years, saving more than $1 billion and 6 years of work. So that's where we see the world going. It's about now that at the end of the hype of generative AI, there are many more AI models, federated AI, convolutional neural networks, GFR, many AI models that you can mix with physics, biology, chemistry, and that's what's really going to impact the economy and what's really going to change every company. But doing that, you need to do it in a responsible way and using ethics. And I think Natalia, you guys at EY have done a lot of work in this field, right?
Yeah, absolutely. And obviously we're an insurance company as well, and it's in our blood to be, to have trust, to be cautious, to think about quality and ethics. And the message I guess I would give to everyone is that responsible adoption is not a constraint. It's actually an enabler. It's actually a competitive advantage. The key thing is that you need to embed responsibility into every stage of the AI lifecycle. Of all organizations that have integrated AI at scale, we find that actually 1/3 of them don't actually have the right guardrails and the right controls, and that's quite worrying. I think that's where the risk begins to really emerge, because at the end of the day, you need to have those guardrails because we know that these things are imperfect. And at EY, we actually have the 9 responsible AI principles that we have obviously helped a lot of clients with, but also really taken them very, very seriously and put them at the core of everything we do in all of our systems. And I think we've learned a lot of lessons with this piece around responsibility and ethics. First of all, I think we need to be very, very conscious that you need to have governance by design. You need to have an operating model where accountability, where transparency, where fairness are built into the development and also into the deployment, right? And that has to be the case from clear roles to risk management, frameworks to continuous monitoring. You need to have this in your operating model. The second thing I would say is that it's a life cycle risk management piece. It's something that basically starts from ideation all the way through to retirement. You can't have this be a compliance exercise. This needs to be built in, really, and embedded controls across the board. And the third thing, and I'm going to come back to this piece, is culture and confidence, because technology alone isn't going to deliver value, right? It's not going to be delivering trust. You need to have the human in the center for that, and leaders need to foster AI literacy. Right? At the end of the day, you have to have people creating a culture, or creating a culture that makes ethical decision making as important as how quickly it's evolving or how much you're innovating. And that is a cultural piece, that is a behavioral piece. So really, I think at the end of the day, organizations that operationalize responsible AI are going to be in a better place because they're going to be able to create trust, and that's going to create long-term value. And that's what I would really say is it's a mindset shift between thinking about it from a controls perspective, thinking about it as an actual enabler to get better results. But responsible AI isn't just about fairness and transparency. It's also about resilience and about security. And we need that governance, I think, to go beyond the models, right, to the infrastructure. And so I guess a big shift coming in is cryptography as quantum evolves. So I want to get your views and perspectives on how that's evolving.
How many of you have heard of the quantum thread or Q2 day? Raise your hands. Okay, I'm going to tell the story. Well, some of the Q, the A is for AI, the Q is for quantum. We started playing with both technologies 7 years ago, using AI to understand more of the quantum technologies, and using some quantum technologies also to understand better how AI works. And we ended up doing a lot of applied technologies today where there's some relationship between the two of them. One of the things that we discovered 7 years ago was post-quantum cryptography and the field of the threat of quantum computers. So I'm going to explain really quickly for those that are not familiar. Basically, in 1994, Peter Shor at Bell Labs published algorithms that say if one day we have a quantum computer, this algorithm can break all encryption as we know today. All the messages, everything we share with each other is encrypted. People can steal it, but they cannot read it. That's what encryption does. Except for the academia field, nobody really cared that much about that publication because there was not a forecast for a quantum computer. Now, in the last 10 years, the progress has been so fast in quantum computers, and now we have a public roadmap from companies like Google, IBM, Microsoft, that we know there's going to be an available quantum computer that can use that algorithm to break encryption as we know it today. So in a few years, all encryption we know will be broken at some point. There's a bigger problem now that's called encrypt now, steal now, decrypt later, which is we know bad actors are stealing your information, they can read it, but they can't store it. They are storing it right now, and they will read it in 2, 3, 5, 7 years when they have a quantum computer ready. So to protect against that, you have to change the entire way we encrypt all the infrastructure that we use, all the applications, everything. This means credentials, passwords, PKI, everything. So we started with this 7 years ago. Nobody was really doing much about it. We're very happy because the market has progressed a lot now. Every bank, every major organization, we're working with EY on this as well. The major departments of defense are working on it because they understand the threat. But what we discovered is that encryption has never been a priority anywhere. Most cybersecurity teams have a lot of priorities. If you talk to the CISO, they basically just want to make it Friday. They're not looking from 3 years from now. So they say, this is the future of tomorrow, and encryption is not a problem right now. But to be able to migrate all the infrastructure, you need to first modernize your encryption, which means knowing what you have, where do you have it, and how can you change encryption. 1 out of 3 breaches that happen out there happen because there is a login or a credential that is being lost or forgotten somewhere, and the infrastructure in major corporations are so big that they really don't know what they have. Literally, people are doing it manually with experts. So the first problem that we have to do, and that we've been working together, is modernizing encryption. By modernizing encryption, you become crypto-agile. And by becoming crypto-agile, you can implement the new algorithms that are being developed by the entire community that are, at what we know today, quantum safe, which means we think a quantum computer and a classical computer cannot break them. So that's what's happening at the worldwide, at every level, for every critical infrastructure. Every major company and critical infrastructure and defense are migrating the entire encryption models. And you can only do that if you have hybrid, what we call hybrid talent. The talent that we have are mathematicians with computer skills, our biologists with computer skills, our chemistry people, computational chemists, computational biologists, computational physicists, These are people that went to college and had the luck that you and I did not have when we went to college. Either you studied IT, or you studied biology, or you studied physics. It was not really combined, but the new generations, this kind of new talent, know how to use digital tools in a very different way than we used to do in the past. And I think EY has had a very great approach to talent and figuring out with all the data points that you have, with all the clients that you're working on, what is the talent that is needed and what the talent needs to study today to be able to find a job in the future or bring value.
Yeah, and not just what they need to study or what kind of talent and skills. It's actually a bigger piece. I think it's at the heart of all organizations, right? Today, I don't know what's going to happen in any of those scenarios, but today it's people, right? So just to give you a little bit of context around our EY story, I mean, we actually have one of the largest private instances of OpenAI in the world. And we were one of the first to market with our own chat enterprise, which we call EYQ. And actually we've had about 80% adoption, 85% adoption of that technology. And equally we have deployed literacy, AI literacy programs across the entire workforce. We've got about 400,000 people at EY. And I think this has been a constant. It didn't start when ChatGPT hit the market, it started way earlier. When we started investing in people, we started building COEs, we started reskilling, because we knew, well, we didn't know what was coming, but we knew that it was really, really key that our talent was prepared for the future. And what I would say is, the reason that I think we've gotten that piece right, and I know we've done many things that we've learned from, but we've gotten that right because of our human-centered approach. We actually found in a big piece of a study that we did at Oxford, that we called Human-Centered, we found that in any situation, whatever type of transformation you are going to do, the likelihood of success typically is about 30% or less. Right? So most transformations actually fail by a number of measures. But what we found is that when you put the human at the center, when you make emotions, culture, and engagement the thing that is in the middle, that actually rises to over 75% in terms of success. And that's really powerful, because in a situation where you're going through a technological revolution, having that emphasis on the person, I think is not counterintuitive, but in a way sometimes kind of forgotten in an organization. So what we've done at EY is really focus on that. So we focus very much on culture. And in culture, we think about culture in terms of collaborative culture, but also in terms of confidence. So from a collaborative perspective, you have to think about the way people learn. They learn from peers, right? You think about community forums, you think about AI champions, you think about contexts that makes things fun. People want to learn from each other, compete, and actually create their own use cases. But the other element of the culture piece, being confidence, is about psychological safety. It's about giving people the ability to experiment safely, to be able to responsibly develop new things and innovate. And I think when we created the low-code, no-code environment we have at EY, we had that in mind. We wanted people to really feel safe to explore and experiment and make that part of their jobs. The other thing is I think when it comes to talent, is employee engagement and upskilling, right? That you've mentioned it. Like the skills that you need today, you didn't need constantly, right? It's going that fast, right? So how do you cope with that? And that talent, to your point earlier, doesn't really even exist in a lot of places, right? It's so hard to find. So I think you need to make a real effort to reskill the people you've got, change their minds, and bring them along with you, with things like role-based learning pathways, all sorts of different personalized academies, or not personalized, targeted academies. We created the EY.AI Academy for ourselves. We deployed AI learning across the board, and we rolled it out to our own people. I've trained about 3,000 people over the last year and a half in our boot camps, right? So when you think about the scale of doing that, it's a huge investment for a lot of companies, right? You need to do it, because at the end of the day, that's your asset, right? And your asset, your culture, the ethos of your organization. We deployed 2.6 million hours of AI learning last year. I mean, it's quite important to do, but I think maybe the most important thing is visible sponsorship and governance from the top. When we launched the EY.AI program, that is our transformation, we had been doing it for much longer, but when in 2022 everything accelerated for a lot of us, right? And when we launched it, the leadership, our board had a very clear vision and made it very, very clear to the people. We put it out there. We've invested $1.4 billion in AI. right? Like it was a no regrets move, and I think we made that be part of the messaging across the board, and we trained all of our leadership across all of the countries because we thought that if you're walking the walk, people will follow, right? So these are some of the things that I think you have to think about when you think about talent beyond what you might think of as reskilling or hiring, as it were. Because otherwise, how can you? The talent just doesn't really exist, right? I think the future workforce is not really AI powered. It's not AI enabled. It's AI powered actually. It's AI plus the humans, but it's really going to be looking very, very different. And the future's arriving faster than any of us expect. I know that we don't have a lot of time. So, what are your reflections, Fernando, as we leave people in the room today? What are your top 3 things that you think leaders should do in their organization, given everything we've talked about?
I think we talked about this last week. We both have a daughter that is a young daughter, and every time I get asked, what are you going to teach your daughter? And I always answer emotional skills, EQ, most of the time, because all organizations everywhere is about humans collaborating with each other. AI is going to help us improve a lot of things, but I think for now, if I think about the future of my kids, it's about emotions and collaboration, empathy. And I think we're running out of time and they're going to get mad at us. So thank you very much, everybody.
Thank you, everyone.